this talk is basically what I found out in this process, right? This talk is not focused on like why you should move away from the cloud or why you should go to on-prem. So it's just for you guys to think about, okay, where does it make sense to move and where does it make sense to stay in place? So we'll go through all the details. So, but before we get started, a little bit about myself. I live in US and also in India. So I have family in both places, so I travel. So also, other than my day-to-day job, I like to learn about cultures and societies. So I like to learn new languages and just be interested in other cultures, right? And then this summer, I'm planning to take a motorcycle drive from all the way from Texas to the Arctic Circle. I don't know if I'm going to make it, but that's the plan. So let's see how it goes. Anyway, so let's talk about on-prem cloud and all, like, why these days people are thinking about, okay, should I bring my stuff back on-prem? So initially, when we moved to the cloud, right, it was because maybe the costs were straightforward. You didn't need to buy a lot of hardware, right? And then but eventually though, as you sort of build new infrastructure and build new applications, you'll notice that you have this cloud expense, like the data transfer fees and the compliance fees. And generally, these go unchecked, right? So you'll have a bunch of resources up and running, and then, but at the end of the month, let's say, you might only be using like 20% of that, right? So you'll have a lot of unchecked proliferation of resources. And then you have to think about the cost of moving the data back and forth from on-prem to cloud, cloud to on-prem, and the refactoring you have to do. So is all that really needed, right? So knowing is the first step to optimizing. So cloud companies, they lack they thrive on the lack of optimization, right? So if you just lift and shift your code, I mean, cloud is not going to magically make your application run faster, right? I mean, just because it's on the cloud. So move, when you think about moving your applications, you should also think about, okay, how are you gonna refactor it? Is it at what level and how many regions it's going to be? So all this you sort of have to think about, right? So what is the real cost of the cloud? So initially, say you have a small application, let's say Twitter, right? Initially, I'm sure for them it was easier to launch a couple of VMs quickly, test something, and then just do a proof of concept and then move on, right? But then let's say as the application grows, I mean, you know that it's nothing but a couple of characters, and maybe you have features which they release, but you know that the general trend is, it's gonna grow, the data is going to grow linearly, but what you'll notice that your cloud costs will grow exponentially, right? It's just the way the cloud is built. The more data you put in, the more transfer you do. It's just a lot of costs are involved. So even though the data is increasing and the patterns are becoming predictable, we are still paying for the dynamic nature of the cloud. So is that really needed if you don't need to spin things up and down at a whim, right? So a lot of times I've been in this situation where I have a lot of resources running and I don't actually, use it to their full extent, right? And I've also gone into trouble a few times. So a while back, I spun up a couple of resources in AWS. It was AWS Elasticsearch, and I was just testing it. It was a new service, and I had it for about a month, and I got a bill for about $40,000 just for testing it. By the way, I wasn't running any production, nothing. So the fact that I just was sitting it idle and not doing anything, you still got charged, right? So if you had a physical on-prem data center, your cost would be the physical server. But then after that, you kind of own that, right? For at least a couple of years. So we'll also talk about later about ROI and how that will look like. So if cloud is all bad, when could cloud be used for, right? I mean, cloud is not bad. So, like I said, small enterprises, they use the cloud, and also large enterprises, surprisingly. So where? So large enterprises, they have data centers, they have hardware, but say they run maybe a promotion, maybe they have some new feature they are trying to release. So it doesn't make sense to invest in a bunch of hardware and then after that promotion or whatever is done, then what do you do with that hardware, right? So so in that case, even large enterprises, they use cloud to sort of do their proof of concepts or maybe like small features really quickly and so on. So if you have a dynamic environment where you need things to be auto scaled at a whim and you know that your patterns are unpredictable, ultimately it's use case specific, right? So funny story, if you guys don't know, AWS, before they started AWS, Amazon, they were selling books, obviously. So, but during the peak periods, like November and December, they had so much load that their normal hardware could not handle. So they bought in a bunch of hardware just for that 2 months. So for the other 10 months, it would just be sitting idle. Only for the last 2 months of the year, the hardware would be used. So Amazon, someone smart at Amazon, they started thinking, well, why do we just keep this just lying there? Why don't we actually do something with it? So that's how AWS got started. So the other 10 months when the hardware was not being used, they sold it as an AWS service. So even large enterprise. So my point being, even large enterprises have a need for this a dynamic way to use their resources and cloud and all that, and that's how AWS, started, right? So ultimately, inevitably, we funded the oops, did something happen? Oh, I don't know what happened there. Sorry about that. It went away from my other screen. Sorry. Sorry, the screen's changed in the middle. Apologize. Okay. All right. As I was saying, okay. So, sorry about the interruption. So, inevitably, we kind of funded the billionaire yacht club, right? I mean, with my 40,000 from AWS and us spending on the cloud every day, right? So, it's a lot of, so how can we rein in some of these costs, right? So first thing that comes to my mind is when you move to the cloud, you have to think about a few things like, is the budget like on track? And, by moving this service to the cloud, like, is there any real tangible benefit, right? And then what applications do you want to optimize, when you want to run. And then also, even though you have a lot of these billing systems available, they actually don't, unless you know what you are measuring for, oftentimes you get the bill and then you realize, oh, wait, I forgot to track that usage. And then you go back and you fix it. So it's kind of like monitoring your systems, right? So something has to go down first, and then you realize, oh wait, I didn't monitor that, and then you add it to monitoring, and then probably after that it will never happen again. But without optimization, moving to cloud, it's just lift and shift, like whether the underlying is physical hardware or cloud, migrating just the applications as is, it's not going to really benefit anyway. And we'll talk about the different ways that apps can be redesigned to make it more cloud native and cloud friendly. But most of the time, just moving it is not going to get much benefit, right? But where does it make sense though? So a common, use case that I have seen is AI/ML workloads. So generally, GPU processing is very expensive in the cloud. So, and the hardware is also expensive, but the thing is, if you get the hardware, right, you can use it for say 4 to 5 years. So say an NVIDIA GPU box is like 250K euros, right? And then you pay the cloud every year, let's say 100K euros. So over the course of 5 years, you're paying almost half a million euros, right? But then the hardware would come for 4 to 5 years. That would be 250. So you kind of have to see where it kind of makes sense financially, and also another advantage with GPUs, at least, because since they use a lot of storage, having them as close as possible to your other applications which consume it will kind of make your entire pipeline sort of move that much faster, right? So if you have other systems already on-prem, then you would benefit having GPUs as well on-prem. And generally, you would want to deploy this on high performance Kubernetes native type workflows. It doesn't have to be Kubernetes, but my point being, it has to be something homogeneous, whether you are hybrid cloud, multi-cloud, or on-prem. You want to make sure that you are standardized your tools, your processes, your pipelines across all the infrastructure. Like, you don't want your developers and engineers to have a different process for each of the environments they are trying to access, right? So it's not just a hassle for them on their day-to-day, but also in their code. Now you need different logic gates for each of those scenarios based on which environment you are. So, but all is not fine, right? I mean, there are some challenges when you do this type of a migration back and forth, right? So one of the most common things that I have found out is the lack of on-prem hardware knowledge, or lack of hardware knowledge in general. So what I've noticed in the past 10 to 15 years is the cloud and the API way of launching things, it sort of desensitized your day-to-day DevOps engineer from knowing actually what the underlying hardware is. So, I mean, it's funny, even today when I ask some DevOps engineer, show me where the cloud is, they point to the sky, right? Which we all know is not true. It's ultimately, it's all hardware, has software. It's all abstracted in a way where, they don't have to think about the hardware. But unfortunately, when you bring your stuff on-prem, you have to think about, okay, now what am I going to do with if a drive failure happens? Am I going to let my SRE and DevOps spend 8 hours a day changing a hard drive, which I did, by the way. So me in a previous life, being the only DevOps engineer, I was not only responsible for the systems automation, but also like the hardware. So I spent with the data center remote hands like several hours and sometimes even several days trying to rectify a physical hardware issue, right? So that's one of the main challenges that I've seen. The second one is the cost. Like I mentioned, overall, cloud might seem cheaper, but then, I mean, the hardware might seem cheaper, but it's expensive in the beginning, right? So when you have to do that initial investment, that would be, and it's not just one hardware, right? What if that one hardware, it goes down? Now you need like a secondary backup, which is not being used, just sitting idle in case the primary goes down. So you need to, now you're spending not just 250, you're spending 500K to get that redundancy, which you don't need in a cloud, right? You can just have another instance up and running, and then that's that, right? And also some of the tools the folks use. So because, folks start with AWS or GCP, some cloud in the beginning, they tend to get logged in, and that would become a detriment when you want to untangle from out of it. And not just on-prem. Say you want to go to multi-cloud. Like these days, even the strongest of the strongest proponents of clouds say you at least need to diversify yourself into like another cloud provider, not just a region, right? Another provider like GCP, Azure, or maybe your own your own private cloud, right? And so the reason for that is that you have more a diversity, and you start thinking about in ways where you don't get locked in, because naturally if you have to launch something in a GCP and AWS, you will think outside of just the AWS box, right? So that's another thing. And also reverse cloud migration. So when it newly came, folks got very excited and they're like, yes, it's like the AI thing. Now everyone wants to go AI, whether there's like a rhyme or reason or not, we want to do AI, right? So cloud used to be that 10, 15 years ago. We don't care whether it'll actually help us. My competitor is in the cloud. I want to be in the cloud too, right? So they hastily move and they realize, wait, things are not only not improved, but they are slower because hardware has a lot of resources. And in the cloud, you need to sort of get multiple resources together to sort of get that scale, right? So people tend to, not realize this, and then they say, wait, now I will move everything back, and that causes a double the work and all of that. And last but not least, I used to be one of these people. I used to be a hard proponent of cloud. Like I wouldn't hear any other way, even if my boss would say, let's think about on-prem, I'd be like, nope, it's cloud or nothing. But slowly I've realized that it's not like strictly that black and white. I mean, you kind of have to think about what's good for your business, what's good for your application, and then do your decisions like based on that. So the way I like to think about this is I don't like to think about cloud as a location, but more of like an operating model. So what that means is whether I'm in multi-cloud, whether I'm in hybrid cloud, or whether I'm fully on-prem on Kubernetes or something, I make sure that my processes and the way my end users are accessing the infrastructure and their experience is as harmonious as possible, no matter which environment. They should only know that, okay, I can deploy resources in east, west, wherever, right? They don't need to know about the intricacies of, okay, where is it? Is it GCP, Azure, on-prem? They don't need to know that. So some of the things you can think about to sort of abstract the end users from this is sort of developing your CI/CD concepts in a way where you have full control over them, right? So what I mean is, for example, artifacts. Try to build your own artifacts and try to have your own security policies and use that as sort of like the base version for your other artifacts and images, right? And I'll go in a little bit detail on how to build and all that stuff. And also the artifact repository. So make sure you have access to that. Make sure you have like a cache or a copy of it in each of your regions where you have your infrastructure, and make sure that your CI/CD pipelines are generally, you use like, for instance, engineers will commit code to like a Git repo, and maybe some automation like Jenkins, GitHub Actions would pick that up, and then artifacts are built, versioned, and pushed, right? So all this should be tracked, and if any new person were to come into the organization, right, they should be able to sort of see the GitHub repo and sort of get a rough idea of like, okay, where are our regions, where are our infrastructure. So you should definitely avoid pressing buttons and all that stuff, right? A continuous delivery, things like having different environments like dev, stage, prod, validating in those previous environments before pushing it in production. And for me, as a DevOps engineer, even a dev environment, I would consider that as a production, and I'll tell you why. So as a developer, when you want to deploy something, you can't just skip the steps and just go to prod, right? I mean, inevitably you're going to miss something, you're going to break something, and then you have to roll things back. So you have to go through that process of a deploying dev, a test, and then stage, and then prod. So if dev is down, they can't just skip dev and then go to stage. So as a DevOps engineer, I make sure that even dev is up 24/7. So it should not be down. And in fact, I have a separate dev called infrastructure dev. So sometimes I'm so paranoid that if even deploying something in dev, I deploy it in the infrastructure dev. If nothing goes down in that, then I do it in the developer dev environment, right? So that might be a bit extreme, and because we had a lot of developers, so I had to do that. But you can do it any which way, right? And that's where the SLA inversion comes into play. So when the dev environment is down, it indirectly affects your SLA in production as well, right? Because if you can't say something is down in production and you have to push a break fix, and if you can't do it via dev, then you can't go to production either. So you have this situation where inadvertently the dev environment also has to be up and production ready, right? And in general, make sure everything is in infrastructure as code, version controlled, and designing your application in. So the 12-factor app is just one of the ways to design the app. It's not the only way. It's basically it gives you some best practices to design cloud native apps, like using environment variables, not hard coding stuff. Make sure you're able to deploy your application across multiple pods or servers, and they should be able to talk to each other. So all these best practices they instill, and which will help you in refactoring the app in case you were to move or make them cloud native, right? So if I were to show this in a diagram or an image, I would split this into two pipelines, right? So a build pipeline and a deployment pipeline. So in the build pipeline, I always pull my images from upstream, and then I build a custom artifact. And I'll go into detail what those L0, L1, and L2 artifacts are. And once I build that artifact, I push it to my local registry, and then I test it maybe with something like Vagrant, and then the build part is done. And after that, I have the deployment pipeline where I use something like the deployment manager, CDK, and it doesn't matter which environment. It can be Kubernetes, On-Prem, Azure, GCP, anywhere. I want to make sure that though the infrastructure as code deployment, it's able to homogeneously deploy the infrastructure anywhere I would want, right? And this is actually very important because a little tangent on a story, right? So a couple of years ago, I was supposed to upgrade Redis on our infrastructure. We had about 550 nodes, and what happened was we were pulling the packages from upstream, right? And we had to update the version. So we haven't updated yet. All we did was we were testing it. So we added a comment in the configuration section, and we were while testing, because we were pulling the packages from upstream, when we ran the Ansible or Puppet, whatever we were running, it saw that a newer package was available upstream. And not only did it pull that package, it installed it across all 500 servers without anyone knowing, right? So no one realized until 10 minutes later when it was taking. So we were using Redis mainly as cache. So our SQL servers were going down. They're having so much load, and we just couldn't figure out what was going on. And then finally, we realized that all the packages got upgraded, and we lost a lot of cache. And then it took us a whole day to bring the Redis infrastructure back up, right? So after that, we moved the package internally, and anytime we now upgrade a package, it's a two-step process. Not only do we have to update the version in our configuration management, we physically have to put that package in our repository, or else the Puppet run or Ansible run will fail, right? So these are some hard-learned lessons that I wish I knew beforehand. And yeah. So we also, after this incident, we we wanted more control of our artifacts, so we started baking our artifacts. So what that means is our Redis, we had a specific artifact for that, which not only had our code, like our security policies, monitoring, and all that, we also had the actual Redis package as well. So when the instance used to come up, all we had to do was do the configuration file in Redis, but the rest would come up within like maybe like 30 seconds, right? And we also had a couple which we just had a generic artifact. So it didn't have any application specific stuff. Maybe we had a couple of monitoring, maybe a couple of security policies, but no application specific code. So the advantage with this is I can use this across multiple applications because there's a balance between how many custom artifacts you want to build, because that's a lot of things to manage. So unless you really want full control over a specific application or artifact, you would generally want to balance this out, right? So a downside for this is you don't know at the time of launch whether it will install properly, whether the package is available, and sometimes it can take a lot of time if the size of the package is huge, right? So both have their advantages and but one thing I would like to say is whenever you build the L2 artifact, always build it from your L1 artifact. So L1, you pull it from upstream, and then you have your security policies, and you push it in your own private registry. But then when you build your L2 artifact, don't pull that from upstream again. Try to build on top of what you already built. So you have a base image where you have your existing stuff, and then you can install your application specific stuff. So the one disadvantage with this method is if there is a vulnerability in the L1 artifact, let's say a TLS, or SSL, these issues, any artifact that L2 was built off of, you have to now rebuild all of them because you are rebuilding L1. All those will become obsolete now. You have to rebuild. So you have to keep that in mind. So some of the tools that are available that you can use, like, don't worry about the names. Names don't matter. What you need to think about are what you want to use for image building, for your infrastructure testing, for service discovery, for your secret storage, and your infrastructure as code, CI/CD, and so on, right? Like, I'm not endorsing any of these tools, by the way. I haven't even used all of them, only some of them, but these are some of the ones that are out there. Another thing is try to think of your infrastructure, as not like a unicorn, right? Like make sure you don't have any snowflakes. So make sure everything is codified in a Git repo versioned, and you don't want to have any instances where you have this one resource running by itself, and then if it goes down, it can take your entire infrastructure down, right? So you don't want to be in that situation. Always ensure that you have either, if the application has a backup, take backups, but ideally, if you can set up in like a clustered mode, like a primary, secondary, or multiple nodes, so that would generally be the recommended way, right? And when you think about networks, don't just put everything in one network, right? One public network. Make sure you have the segregation of public, ops network, and air-gapped network, and so on, right? So in a diagram, the way this would look like is you have the ops network where you have maybe Ansible, your registries, your artifacts, and all those are there. So the ops network can talk to the internet, and it can pull packages and all of that. And you have the public network, which can also talk to the internet. And then you have your APIs, your web app, all this stuff will be in the public network. And what you see underneath there is the air-gapped network. So there, the air-gapped network, no one from the internet can talk to it, and it cannot talk outside either. So it cannot ping, it cannot come outside. But then how does it get all the packages and all that stuff, updates? So everything will be in the ops repo. We have update servers, registry servers, everything, and everything is scanned and make sure there are no like unintended packages, right? So all the sanitation happens in the ops network. So when your secret servers, when your databases, when your storage, when they pull the information, the packages, they know that they're getting a trusted package from within your environment, and it's not being like injected from somewhere, right? And same thing with your public network. So your application, all that will access your databases and all of that via the air-gapped network, right? And even if you have two sites, let's say, one in west, one in east, you can still talk between the air-gapped networks via like a dark fiber WAN link or any of those fiber links to be able to do that. So some of the if I'm honest, these are the three main things that you would probably need to think about if you were looking into migrating, not just the cloud to on-prem. Even if you're on-prem now, you are looking to move some of your stuff to cloud. Think about the on-prem hardware knowledge, right? Like the team you're assembling or your existing team, do they have the hardware knowledge? Like, are they going to be able to? I'm not saying they have to go in a data center and physically fix the hardware. No, I'm just saying they should at least know that okay, there's a drive failure, and I need to talk to the data center to sort of replace the drive. So all that is, it's an involved process, right? And I think of cloud as like an operating model, right? So no matter where you have your resources deployed, use some of the cloud native tools we talked about to ensure that you don't have unique tools in each of the environments and so on. So if you're logged in already, that could be a challenge to untangle from that stuff, right? And then in general, using best practices and cloud native rules across your hybrid environments and so on. So the three types of engineers that, in my experience, that have made this successful, and it's not a quantity, it's the quality. If you have one really, really, really good data center engineer and one really, really, damn good DevOps engineer, you can manage even up to like a 2000 node data center. Like I've done that. Like it's not that difficult as long as you have your ducks in a row and you're not like running around each time. Everything is monitored. You have backups. You have automation in place. It is possible, right? So, and I've seen companies with like 20 data center engineers and 50 DevOps engineers who could not even run, a small adjacent. So it all depends on like getting the right people, and also last but not least, the application developers. They not necessarily need to know hardware, but they would need to sort of know that, okay, I would need to work with hardware, so I need to account for that. So they need to be familiar with it, right? So if they need to make some kernel modifications or something like that, they should know that, okay, this is our on-prem site, and here you can do. Maybe in cloud at hardware level, sometimes you cannot do, right? So am I saying, okay, close everything where we have right now, move to the on-prem or cloud? No, like what I'm actually trying to say is like, just have an open mind. Don't be like me where, fighting with your boss, like, this one thing is the best thing, everything else is crap. So have an open mind and see for your company, like what makes sense to actually deploy and get some benefit out of that, right? So ultimately, there are a couple of things you are trying to do. You are trying to save costs. You are trying to make your application fast. You are trying to do this in an economical way, and you're trying to have more control over the things, right? So some of the industries that are looking to do it, this type of thing these days, are you have your banking, your health sector. Like these companies, they went to the cloud reluctantly. What I mean is, they saw the scale and the power of the cloud, but they didn't like the security aspect of it. Like they didn't like the fact that their financial data even though it's at a software level separate, still at a hardware level is being shared by, I don't know, some a Craigslist site, I don't know. So they did not like that. So now that there are these tools available for you to build essentially your own cloud wherever you want, on-prem, your own hardware. Now, these sectors like oil and gas is another one, which are pushing, for more on-prem, and they want to do more hardware, but they want the same features of the cloud, right? So it's a mixed bag, and yeah. So ultimately, it's up to use case in each industry. It's a bit different, but yeah. This is what I think about every day. I work with engineers on this every day. I work with them trying to, like, I not only do the architecting, but I also write the code, write the Terraform code and the infrastructure code, help them deploy it, manage it. I actually love doing this stuff, and especially working with new startups and who are kind of hesitant to foray into the hardware on-prem. They're like a bit hesitant. So I show them like, hey, it's not that big of a deal. It's just, it's just like cloud, some extra bits. So, but yeah, I would, if you would like to talk to me after the conference, yeah, I'm on LinkedIn. You can reach out to me. But yeah, thank you for your time.
Any question? Okay,
Come on, it couldn't have been that clear. There must be some questions. Yeah. But yeah, no, yeah. I mean, if anyone has any questions, feel free to interrupt me. Right. So, but yeah, no, just 2 minutes, right? Yeah. So, these things, when I work with new startups and all of that, it's very interesting because they are still sort of in this learning phase, and they're trying to understand, like, okay, where not only are they designing an app, now they have to like learn the hardware bits as well. So yeah, no, it's pretty interesting how folks can sort of pick up on this easily. So one thing I've noticed is even if the DevOps engineer is not familiar with hardware, if we like help them and train them within like a few weeks, they tend to pick up very quickly. Like, I mean, I haven't had any issue where an engineer was like, no, I cannot do hardware at all. I'm out of here. Like, as long as you don't make the engineer spend 8 hours to fix the hard drive, like that would be a gross waste of time, right? I mean, you don't want your SRE DevOps working on hardware for that long. That's why you need data center engineers who can focus on this. They can probably fix this within like 1 to 2 hours because that's their job, and that's their focus. So having these two separate roles, I feel like is very, very important. But yeah, if there are no questions, yeah, I'll be here. So if you guys have any questions later, also, please feel free to come by. All right, cool. Thank you so much, everyone. I appreciate it. Thank you.